Okay, welcome back again. And if you remember the last lecture, we were talking about the fundamentals of probability. We briefly described what probability was, and as you can remember, probability uh, has a number of synonyms like chance, like likelihood. So we ask questions like, what is the chance that it's going to rain today, or what is the likelihood that you're going to pass this class? So we gave different examples for probability. We gave an example for the coin. When you flip the coin in the air, the probability of getting tails is 1.5, right? And we also gave an example on the dice. When you roll the dice, the probability of landing one side is 1/6. It means the probability of getting one is 1/6 because there are six different possibilities and we are only looking for one successful outcome, and 1/6 will give us that value. uh, in this lecture, we'll get into more details about the probability. We'll get into more complicated problems to understand how probability problems can be calculated by different ways. Okay, what I mean by different ways, what if we add conditions? What if we add certain conditions to the problem? So how is that going to change the calculations of probability? All right, so let's work on an example. Okay. Let's assume that we have producers or manufacturers. Okay, let's call them producers. And those producers are producer A, producer B, producer C, and producer D. Those producers manufacture parts, and sometimes they manufacture good parts, and sometimes they manufacture defective units. So the good parts and the defective units okay, so let's assume that producer A has 40 good parts and 4 defective units. Producer B has 36 good parts and 5 defective units. Producer C has 42 good parts and 3 defective units. And producer D has 70 good parts and 2 defective units. So since we know the number of good parts and the defective parts, that means we know the total parts that those producers manufactured. So 40 plus 4 is 44. This is going to be 41, 45, and 72. So in total, those 4 producers manufactured 202 parts, right? And those 202 parts contain both good parts and the defective units. Okay. So the question that we want to ask, let me use a different color. Question number 1. Okay, so let's assume that, okay, we're just making an assumption, and let's assume that we gather all this 202 parts in a container. Okay, if we gather 202 parts in a container or in a box, we want to look for the probability of selecting a random part. So we say, what is the probability of selecting, let's say selecting a random part, from producer B or D. Okay, so what we're looking for the probability of P or D. That means we're looking for the probability of PB plus PD, right? So let's go back to the question and let's just reread it. It says if we gather all 202 parts in a container, so that means they're all in the same container, they're all in the same box, regardless of the condition of the item. So we don't differentiate between the good parts and the defective parts. 202 contains all the good parts and the defective parts or the units manufactured by producers A, B, C, and D. Okay, and we're looking for the probability of selecting a random unit or a random part from producer B or producer D. Okay, so we're looking for PB or D, that means PB plus PD. So the probability of selecting a random unit from producer B is what? Okay, so again, a random unit means we are not looking for a specific part. We are not looking for the good part. We are not looking for the defective part. We are looking for any parts that is produced, or we are looking for a single unit that's produced by producer B. And that number is 41, right? So 41 divided by 202. Okay. So the probability of selecting a random unit from producer D is 72 divided by 202. So this is 113 divided by 202, and that's about 55%. Okay, so the probability of selecting a random part from producer B or D is about 55%. Again, whenever I use the term of or, let's use green this time. Whenever I use the term of or, that means selecting a part from producer B or selecting a part from producer D will satisfy my needs, will satisfy my conditions. So either chance will work for me. This is why we add those two numbers up. All right. Okay, so let's work on another problem. Let's say that we want to calculate what is the probability of selecting a good product from producer A or a defective one from producer B. Okay, so this question is quite similar to the previous question that we worked on. The only difference is that this time we're looking for the probability of selecting a good product from producer B or a defective one from producer B. So a good product from producer A and a defective one, or a defective one from producer B. So we're looking for probability, the good product, or let's just put it in this way. We're looking for a good product from producer A and we write a defective product, right? Defective product from producer B. Again, we're looking for the probability of selecting a good product from producer A or a defective one from producer B. So that means we're interested in finding PA good plus PB defective, because selecting either a good product from producer A or selecting a defective unit from producer B will satisfy the condition in the problem. Okay, so what is the probability of selecting a good product from producer A? Well, that number is 40, right? Because we have 40 good units from producer A, and the number of possible outcomes is 202. Okay, and what is the probability of selecting a bad unit or a defective one from producer B? And that number is 5 out of 202. So that means 45 divided by 202, so that's about 22%. There's a 22% chance, or there is a 22% probability that we'll be selecting a good product from producer A or a defective one from producer B. Okay, so let's work on another problem. Okay, so let's work on question number 3, or problem number 3. In problem number 3, we'll be adding more conditions to the problem. So we're looking for the probability. What is the probability of selecting a random unit from producer B, or a defective product, or a defective unit, from producer A, okay, so let's add another condition to the problem, and let's say that we're also interested in selecting a good product from producer, or a good product from producer C. Okay. All right, so what we're interested in finding the probability of selecting a random unit from producer B, or the probability of selecting a defective unit from producer A. So this is A subscript defective, or we are looking for the probability of selecting a good product from producer C. Okay. All right, so that means we're looking for PB plus PA defective plus PC good parts. And probability of selecting a random unit from producer B is 41. So 41 divided by the number of possible outcomes, that is 202, plus a defective unit from producer A, which is 4. 4 divided by 202, and a good product from producer C, and that is 42, and 42 divided by 202. So the total becomes 87 divided by 202. Okay, let me use my calculator to find the percentage. 87 divided by 202, so that's about 43%. So this is about 43%. Okay. All right. So on the next problem, which is question number 4, we'll be adding an interrelated condition. So let's work on the example to see what is an interrelated condition. So let's assume that those 202 parts described in the table are gathered together. So they're all kept in the same container. And we're looking for the probability of, let me use black. So what is the probability of, selecting a random part, selecting a random unit from producer B, or simply a defective unit, or simply a defective unit. Okay. So to visualize the problem, let's draw a Venn diagram. I hope that you recall what a Venn diagram is. So Venn diagram looks something like this, right? So the number of products from producer B is 41, right? Because we are only looking for a random unit from producer B. So that is 41. Okay, so that 41 includes what? That 41 includes 36 good parts from producer B and 5 good units from, 36 good parts from producer B and 5 defective units from producer B. So that makes it 41. Okay. And number of defective units, okay, because we're interested in finding a defective unit. So if we add all these numbers up, that's going to be 14, right? So the number of defective units is 14. So this is defective. Okay. Well, when we calculated the number of defective units out of 202, we also considered 5 in 14, right? So that means in this problem, there are 5 defective units, or there are 5 defective products common to both events. Okay, so that 5 is used in the first part of the problem, I'm talking about this 5, and that 5, the same 5, is also considered when we calculated the total number of defective units. So those 5 defective units are used in 2 different cases in this problem. Okay? So what is that supposed to mean? That means the 5 units are counted twice here, right? And we want to remove one set from our calculation. We don't want to use that 5 twice. We only want to use it once. Okay, so how do we formalize this? PB plus P defective minus PB and defective PB and defective in common. So this is the common part. So we want to remove the common instance from the study, from the calculation. Okay, so let's do the calculation, and that's equal to 41 divided by 202 plus, okay, 14 divided by 202 and minus 5 units divided by 202, because those 5 units here are counted twice, so we want to remove one set from our calculation. So the total becomes, let me use my calculator, so that's 50 divided by 202, right? 41 plus 14 plus 14, that's 55. 50 divided by 202, that gives us about 24.7%. 24.7%. Okay, perfect. Okay, since the beginning of this lecture, we'll be using the OR term, right? So we were looking for the probability of selecting a good part from producer A, or selecting a defective unit or a good unit from producer B. So we're switching from OR to AND. So this time we'll use the AND term to solve more problems on probability. And this will also make us understand the difference between using the AND term versus the OR term. Okay, so let's work on an example. Again, we're assuming that those 202 parts are contained in a are gathered in a box or in a container. Okay, and we are looking for the probability of selecting. So what is the probability of selecting 2 randomly parts from producer A and producer B. Producer B with replacements. Okay, so this is the keyword. Let me just underline it. With replacement. So what is that supposed to mean? With replacement means you draw for the first product, then you return that first product to the box before the second part is selected. Okay, so you go for the first row, you pick up the part, and before you go for the second row, you put that item back into the box or back into the container. This is what it means by with replacements. Okay, so in this specific problem, we are looking for the probability of selecting two random parts from producer A and producer B. Okay, so in our first attempt, that's probability A and probability B. Okay, so that is PA times PB. So in our first attempt, we're looking for the probability of selecting a good product, or I'm sorry, the probability of selecting a random product from producer A. So that is 44 divided by 202, right? We know how this figure is calculated because the total number of products from producer A is 44. So 44 divided by 202, okay? So we pick up the item and we return it back to the container. So the total number of units, the total number of parts will never change because we already returned the first item that we picked in our first attempt. So we still have 202 items. So this time in our second row, so that was for part number 1. So this is part number 1. For part number 2, we are looking for the probability of selecting a random part from producer B. So that's 41. That's this number here, 41 divided by 202. Okay, so if you calculate the number, if you calculate those numbers here, so the total should be close to 4%. Okay. Okay, so let's change the question a little bit. So I'm only going to change this question 5 to question 6. So this is going to become question 6. And I will also change the keyword that we use with replacement. So this time, let's look for, give me 1 second, let me just erase that. So this time, we are looking for the probability of selecting two randomly parts from producer A and producer B with no replacements. Okay, with no replacement means what? The first part that you selected in the first row, okay, you keep it in your hands. You don't return it back to the container or you don't return it back to the box. You hold it. And when you go for the second row, that means the remaining items is going to be 202 minus 1. So that becomes 201, right? Because you already, in your first attempt, you already pick up an item out of 202 units and you kept it. You did not return it back to the container or you did not return it back to the box. You held it and you go for the second row. So that means you'll be ending up with dealing with 201 units. So 202 minus 1 will become 201, right? So the only thing that changes actually, so this portion will remain the same. So we're still looking for the probability of PA and PB. So that means PA times P to find P given A. And that number is going to be 44 divided by 202. And this time, 41 divided by 201. Again, we held the item that we selected from the first event or from the first trial or from the first row. Okay, So that number becomes, I think it's also about 4.4% or something. You can make the calculations, and it's going to be somewhere around 4.4%. Okay. All right. So remember, this time we're using a different term. We've been dealing with or since the beginning of this lecture, and this time we changed the scenario and we used the and term to find the probability of selecting two randomly parts from different producers. Okay, so let's work on another problem. What is the probability of selecting two randomly parts from... Oh, I wanted to use black. Parts from producer C. Okay, so what we're looking for is P, C, and C. Okay, so that means we're looking for PC times P to find C given C, and that number is 45 divided by 202 times, so 45 comes from producer C, times 44 divided by 1. Okay, but our assumption is that it's with no replacement. Okay, so you go for the first row. There are 45 items, right? And 45 items out of 202. And as soon as you pick up the first item, you don't return it back to the container. You hold it and you go for the second trial. So that means the remaining number of items from, or the remaining number of units from producer C is 1 less. So 45 minus 1 is 44. And the total number of items is also going to become 201. So 45 divided by 202 times 44 divided by 201. Again, I want to repeat this part. So in the beginning, for the first part, this is part number 1. Okay, there are 45 items that comes from here. There are 45 items that come from producer C, regardless of the item's condition, regardless of the unit's condition. 45 items. So the probability of selecting a random product from producer C is 45. And the number of possible outcomes is 202. So 45 divided by 202 will give us the first part of the problem. Okay. So then you pick up the first part and you hold it because it says with no replacement. No replacement means you do not return it back before second part is selected. Okay, so you do not return the first part back to the container. You hold it, you kept it out of the box, and you go for the second trial. So this time we are 1 unit less. So that means we're going to be dealing with 44 units instead of 45. So 45 divided by the total number of units, which is also 1 less because we already picked up 1 item and we already kept it out of the box. So 44 divided by 201 will give us the second portion. So this is for part 2. And when you do this calculation, the total should turn out to be about 4.8%. All right, so let's work on the last problem. We are looking for the probability of, so it's what is the probability of what is the probability of, or what is the probability that two randomly selected products will have one good product from producer A and one good product from producer B or C, and that is with replacements. Okay, so let's read the question. What is the probability that two randomly selected products will have one good product from producer A and one good product from producer B or C? So there are a few keywords here. The first keyword is with replacement, and the second keyword is the AND term, and the other keyword is the OR term. So we're using AND slash OR together in the same question. Okay, so how do we do this? So we're looking for the probability of selecting a good product from producer A and selecting a good product from producer B, or selecting a good product from producer C. Okay, so that means we're looking for PA times the brackets PB good unit plus PC good unit, and that's the bracket. Okay, all right, so the probability of selecting a good part from producer A is what? That's 40 divided by 202, right? All right, it says with replacement. So we went for the first row and we took the item out of the box, then we put it back into the box again. Okay, so the remaining number of items will never change. It will remain the same. It's still going to be 202. Then you go for the second round. You either want to take a good product from B or a good product from C. So what we're looking for, what we're interested in, is probability of getting a good product, 36 divided by 202, plus 42 divided by 202, because the number of good products that come from producer C is 42. Okay, when you do the calculation, the total should turn out to be, so let's just do the calculation. So that part is 78 times Okay, let me just do the calculation. That's 202 times 78 divided by 202. So the total is going to be somewhere around 7.6%. Okay. All right. So this is it for this part. For the probability lecture, we understood the fundamentals of probability. We used two different terms. We used or and the and terms together, right? We also use with replacement or with no replacement type of questions together. Just let me know if you have any other questions or if I can help you more. If not, then I'll see you in the next lecture.